Right, guys, welcome to the products video for the answers to exercise 1, which was just involving simple distributions. I hope you've tried them, because if you haven't tried them, there's no point in watching this video. Right, let's start at example A. It says simplify the following. Now, when I look at this, I see one term outside the bracket, and I see 3 terms inside the bracket, and there's nothing separating this term and the bracket, which means I'm multiplying. And that immediately says to me distribution, because there's more than one term in the bracket. So I'm going to distribute in my negative 2a squared. Just a reminder that I always say to myself when I'm multiplying, I do the signs first, then the numbers, and the letters. So negative 2a squared times negative 3a. Signs. Negative times negative, positive. 2 times 3, 6. A squared times a cubed. Next, negative 2a squared times positive 5b squared. Sign times sign. Negative times positive, negative. 2 times 5 is 10, and my letters was a squared, b squared. And finally, negative times negative, positive. 2 times 4 is 8, and a squared times a cubed was a to the power of 5. I should always check if there's any like terms, which clearly here there isn't, and so that is the simplified answer for A. Right, let's look at B. This is an example of a binomial times a binomial, which means I'm going to distribute in my first term, and then I'm going to distribute in my second term, and then hopefully add up like terms. So if I distribute in my A, I get a squared plus 7ab. Every single time I'm doing signs, numbers, variables in my head, minus 3. Now notice I write this as AB. I always write alphabetically to help me with like terms in the end. Minus 21b squared. Now there are some like terms here. I have 7ab, take away 3ab, which gives me a squared. These two give me 4ab's minus 21b squared. And I'm done. Right, let's look at C. Again, it's a binomial times a binomial, so I'm getting used to this. Distribute in my first term and distribute in my second term. So 3 times 3, 9, plus 6x minus 3x and minus 2x squared. Always check for like terms, and again, there's some like terms here. So I get 9, I get plus 3x, and minus 2x squared. Now, it doesn't matter the order in which you write this. So I could have written it as with my x squareds first, and then my x's, and then my 9, which is generally how I'm used to it. I'm used to having the highest exponent for x at the front. That's the equivalent, and so either one of those could be the final answer. You're welcome to move addition around. Right, D looks mean. It's a very simple binomial times binomial. It's just not nice because there's a fraction. So let's distribute in our first fraction. Now, if you want to, write out what you're doing. You're saying x divided by y multiplied by xy. So that would be that first multiplication. Then you're saying, well, positive times negative would be negative x over y times 1 over y. It might be much easier to write out and not to do the fractions in your head. Now, that's easy. That's plus xy. And lastly, that's positive times negative, negative. Now, 1 times anything is it just itself, so I'm not going to bother with writing out 1 times that. It's just 1 over y. Now, what I'd do is I'd simplify each of these. Now, each of those, that's a fraction really. It's just a fraction over 1. So I get x times x at the top, which is x squared. And I have y at the top and y at the bottom. So they cancel, and I'm just left with x squared. Okay, next I've got y times y at the bottom. So there's no cancelling here, and x times 1 at the top. So that's minus x over y. I then have plus xy and minus 1 over y. Now this isn't particularly nice, and there might be like terms. I don't see any like terms with my x squared, and I don't see any like terms with my xy, but actually these could be combined somehow because they have the same denominator. So maybe I could write it as minus x. Now I'm going to write plus 1 over y plus xy. Now why did I write plus 1? Well, have a look. This minus belongs to that whole top. So it would be minus x and minus 1. And there was a minus here. So I've put a plus here so that when I distribute that minus to the 1, it remains minus 1. Now, it's arguable whether that or that is more simple. So I don't think there's anything wrong with leaving your answer there. It's probably technically more simple to write it with one denominator of y, but I don't think it's a train smash if you leave it at this second last step. As long as you're more confident with this second step, with these multiplying fractions by fractions, write out what you're doing. Right, let's have a look at example E. Example E is again very simple. I recognize it. I see it's a binomial times a trinomial. But that's easy. All I've got to do is distribute in my first term and then distribute in my second term and then add up like terms. So let's start. So I'm going to erase that. Let's go. 3x times x squared would be 3x cubed minus 9x squared y plus 15x y squared minus 4 alphabetically x squared y plus 12xy squared and minus 20y cubed. So now hopefully there are some like terms. Let's have a look. X squared y's and some more x squared y's. Here's some xy squareds, and then that's it. So I've got 3x cubed minus 9x squared y minus another 4x squared y would be minus 13x squared y's. 15xy squared and 12 would be 27xy squared and minus 20y cubed. And that's as simple as it gets. Right, last one for this exercise. Now these are 3 binomials multiplied together. There's no ways I want to do this all in one step. So why don't I do that part for now? And why don't I leave this 2a plus 5b untouched? Because it's very easy for me to multiply a binomial times a binomial. I'm just going to do 3a times 3a, 9a squared, minus 3ab, plus 3ab, now I've run out of space, so let me erase, plus 3ab, and minus b squared. That's quite simple to me now. Now this product here had to be multiplied by 2a plus 5b. So now I've just got a mess. But before I even start multiplying, as soon as I wrote this down, I realized, hang on, those two will cancel. So actually this isn't a mess. This is 9a squared minus b squared. Now that looks like the difference of two squares, and suddenly this seems to make sense because that was the factorized version of a difference of two squares. So I think I'm correct. And now this is boiled down to another binomial times a binomial. So some distribution, 18a cubed plus 45a squared b minus 2ab squared and minus 5b cubed. Now I will check for like terms, but I didn't think of any when I wrote it down. And nope, that's it. So those are the answers to our exercise. I hope you did well. Remember to go and find some in a past paper and practice some more.